Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
So it's Tuesday, February 3rd, 2026. And, looking at the calendar, it really feels like we've shaken off the hype cycle hangover of the last few years.
It really does. It's like the dust has finally settled, the speculative bubbles have popped, and now we're seeing what's actually left standing.
Exactly. For years, every conversation was about prediction. It was always AI is coming or get your data ready. But looking at this stack of reports on the desk today, and it is a heavy stack, I think it's safe to say we're done predicting. We are building.
Oh, prediction time is over.
Yeah.
We are so firmly in the operational phase now. The sources are calling this the Agentic era. But I think that sounds a little too clean for what's really happening.
What's really happening?
It's a collision, a messy one.
A collision between what?
Between the massive concrete reality of physical infrastructure and the abstract code that runs on it. I mean, we've got reports here from ML-based systems on construction. We have deep dives on the postmodern data stack from Joe Rees. And then, these really nitty-gritty case studies from Caltrans and Siemens.
So it's a convergence of atoms and bits, basically.
And it is messy. That's what people miss. This isn't some smooth upload to the cloud. It's pouring cement, it's tearing up floorboards for pipes, and it's completely rewriting how businesses make decisions all at the same time.
Okay, so our mission for this deep dive is to map that mess. We're going to trace the line from the construction boom happening right now all the way down to the code running on the chips inside those buildings. So whether you're trying to figure out where to invest or just understand why your IT team is suddenly talking about, entropy, this is for you.
We're moving from just looking at data to data actually doing the work.
Let's start with the physical reality then, because we get so caught up in software we forget the stuff has to live somewhere. You handed me this forecast from MOCA Systems and on Doors. I honestly thought the decimal point was in the wrong place.
The numbers are, they're pretty aggressive.
I mean, they're tracking data center construction spending. They say 2022 was the start of the AI commercialization era. Back then, spending was around $11 billion.
Which is still huge money, right?
Huge money, sure. But for this year, 2026, they are projecting spending to hit $89 billion.
Just pause on that for a second. $89 billion.
That is a 782% increase in 4 years.
It's completely unprecedented. In the construction world, if you get 5, maybe 7% growth year over year, you're popping champagne.
Right.
It's a stable, slow-moving industry. A 782% jump. That's not growth. It's a frantic scramble. It is a wartime mobilization of capital.
So what's all that money actually buying? Is it just more storage for my 8K videos and cloud backups?
No. This is almost entirely driven by AI workloads. But we have to break that down a bit because AI workload isn't just one thing. Right now, we're in what MOCA calls the training surge.
Okay, so distinguish that for us. Training versus, what's the other part?
Training versus inference. So think of training as the university phase for the models. From late 2023 through right now, the hyperscalers, your Googles, your Microsofts, have been front-loading construction to build these massive GPU clusters to teach the models.
And these places have to be dense, right? Hot, centralized.
Exactly. Because you need all those GPUs talking to each other with basically zero latency. You can't have half your brain in Ohio and the other half in France.
The speed of light is your bottleneck.
Literally, it's a brute force engineering problem. But here's the interesting part of the forecast. This training surge isn't forever. Around 2027, the curve starts to shift toward inference.
Which is the application phase. The AI is out of school and has a job.
Exactly. Inference is the model, doing the work, generating an image, answering a chat, piloting a drone. And those workloads don't need to be in one massive hub. They need to be close to the user. They need to be out at the edge.
But before we get to the edge, we have to talk about the heat. Because that's the other thing just screaming from these engineering reports. You can't just stick these new chips in a regular server rack with a fan.
No, you would melt the chassis.
Yeah.
There's a metric called rack power density. And traditional air cooling, literally just fans, it taps out at around 30 kilowatts per rack.
And where are we now with these new clusters?
We are pushing past 100 kilowatts per rack. Air just doesn't carry heat away fast enough. It's a physics problem.
So this is where we get liquid-ready cooling.
Direct liquid cooling, or DLC. We're literally plumbing the servers now. We're running fluid directly to the chip plates. And just think what that means for a construction site. You're not just running power cables, you're running complex, pressurized fluid systems.
So a leak in a server room used to mean a roof problem. Now it could mean your internal cooling loop has just ruptured over $1 million of silicon.
Precisely. And that complexity is crashing right into the other huge bottleneck, the grid.
The MOCA report called this the reality check.
It's the ultimate hard stop.
Yeah.
You can buy the chips, pour the concrete, install the plumbing. But if the utility company says, sorry, no power for 5 years, you have an $89 billion paperweight.
The stats on the interconnection queues are just dismal.
In PJM, that's the grid for a huge chunk of the Mid-Atlantic and Midwest. Fewer than 25% of projects in the queue actually make it to operation.
Less than 1 in 4. That is a brutal failure rate.
It is. The grid is congested. And it's creating this ruthless land grab for what they call power-advantaged real estate. It doesn't matter if the land is cheap. It matters if there's a substation next door with capacity.
So that's the physical body we're building. It's massive, liquid-cooled, and starving for power. I want to pivot to the brain, though. We have this fascinating breakdown from Joe Rees about the postmodern data stack.
I love that term, postmodern. It implies we've moved past the modern era and, well, deconstructed it.
Okay, so let's define the modern era first so we know what we're leaving behind, because that was the buzzword for a while.
The modern data stack was all about the cloud data warehouse. Think Snowflake, BigQuery. The logic was extract everything from your apps, load it all into the cloud, and then transform it there. ELT.
It was the era of the single source of truth?
That was the goal, yeah. But functionally, it was an era of hindsight. You built these massive pipelines just to populate a dashboard that told you, hey, sales were down 5% last week.
So it's passive. You look at the dashboard, stroke your chin, and then you have to go fix it. The human was the middleware.
The human was the bridge between the data and the action. The postmodern stack, this agentic stack of 2026, is about removing the human from that bridge.
This is the core shift, from descriptive to agentic.
Exactly. The stack isn't built to answer what happened. It's built to ask, how do I fix this? And then it executes the fix.
Okay, so give me the inventory management example from the report. In the old world, a dashboard flags that you're low on some product.
And then you, the manager, have to log out of the dashboard, log into your ERP, check supplier contracts, maybe make a phone call, place the order. You're doing all the work.
The data was just a signal, a notification.
Right. In the agentic workflow, the AI is the manager. It sees the low stock. It checks the forecast. It looks at the supplier's API for real-time pricing. It negotiates the shipping rate. It places the order.
And what does the human get?
A notification. Restocked 500 units. Delivery Tuesday.
That sounds incredible, but also kind of terrifying if the data's wrong. If the AI hallucinates a demand spike, you're suddenly stuck with a warehouse full of fidget spinners.
And that is exactly why the Elation report focuses so heavily on this idea of data products. They call it the inedible to edible concept.
I like that analogy. Break it down.
Raw data, the stuff in your data is like raw chicken on the floor. It's messy, it's unformatted, it's probably full of bacteria, it's inedible. You cannot feed that to an autonomous agent.
It'll get sick. Or in this case, it'll make really expensive mistakes really fast.
Right. So data product is the cooked meal. It's data that's been cleaned, governed, verified, and packaged into something trustworthy, like a verified inventory count. The agentic stack only works if it consumes these high-quality data products.
So the job of a data team in 2026 isn't really building pipelines anymore. It's more like food safety.
That is a fantastic way to put it. They are the quality assurance for the AI's diet.
Okay, so we have the $89 billion physical shell, and we have this high-stakes agentic software. Let's talk about where they crash together. The digital twin.
This is where the rubber meets the road. Or maybe the sensor meets the server.
We've got this report from the Construction Management Association, and they make a point about the 80% rule.
This is the core economic argument for digital twins. We obsess over the construction cost, the $89 billion. But that's only about 20% of a building's total life cycle cost.
The other 80% is just operating it.
Exactly. It's energy, maintenance, repairs, staff for decades. So if you can use data to shave just a few percent off that long operational tail, you're saving way more money than you would by just building it cheaper.
And the digital twin is the tool for that. But they call it a living entity, which sounds a bit sci-fi.
Well, it's a maturity curve. Level 1 is just a 3D model. It's a dumb picture. But then you get to level 3, which is predictive.
This motor is going to break.
Right. It monitors vibration and tells you 2 weeks in advance that a bearing is failing. But level 5, Level 5 is autonomous. This connects right back to that agentic theme.
And we have a perfect example of this from Siemens. They call it WSCO.
White space cooling optimization. This is the killer app for those data centers we were just talking about. Historically, you just blast the AC in a data center. It's super inefficient.
It's like keeping your house at 60 degrees in July, just in case you decide to bake a turkey.
Perfect analogy. WSCO puts thousands of sensors on the server floor. It creates this real-time thermal map.
Right.
But, and here's the agentic part, it doesn't just show you the map, it controls the cooling units itself.
So it adjusts the valves and fan speeds on its own?
In real time. If one server rack suddenly spikes in activity, the system directs cooling right there, instantly. If another rack goes idle, it dials it back.
And the payoff on that?
Up to 25% in energy savings. In a hyperscale facility, that is millions of dollars a year. And it happens without a human touching a dial. The building is managing itself.
But that brings us back to a constraint, doesn't it? If you have thousands of sensors in a facility or cameras on a construction site, you can't send all that video to the cloud.
You'd choke the bandwidth. This is the argument for edge computing in the Constro Facilitator report. Imagine a construction site with 50 safety cameras. You don't need to stream 247 video of an empty hallway to a server in Virginia.
It's just wasteful.
And
slow.
So you move the brain to the camera. That's the edge. The camera itself uses AI to watch the scene. And if nothing happens, it sends nothing.
But if a worker walks under a suspended load without a helmet,
the camera processes that locally, triggers an alarm on site, instantly, beep, get out. And then it sends a little clip of the incident to the cloud for the safety record.
the decision happens right on the device.
It's faster, cheaper, and it still works even if the site's Wi-Fi goes down.
Okay, I want to ground this because we're talking about autonomous buildings and self-healing supply chains. It sounds amazing. But we also have a source here from DVTA that warns about the disaster scenario, the data swamp.
Ah, the swamp. It's where data lakes go to die.
How do you end up there?
It happens when you just dump data without context. You have the sensors, you have the logs, you just pour it all into one place with no tags, no schema, no ownership. It just becomes murky. You can't find anything, you can't trust anything.
And as we just said, if you feed swamp water to an agentic AI,
you are in big, big trouble. So the solution everyone points to is actually an organizational one, not just technical. It's called the data mesh.
this term gets thrown around a lot. How does it actually fix the swamp?
It's about decentralization. In the old model, one central IT team was supposed to understand every piece of data in the company. Marketing data, engineering data. It's impossible. They just became a bottleneck.
So the mesh breaks that up.
The mesh says, hey, marketing, you own the customer data. You are responsible for making it a clean, trustworthy product. Engineering, you own the sensor data. You push ownership out to the people who actually understand the numbers.
But you still need some central rules, right? Otherwise, it's chaos.
Exactly. That's the federated governance part. You have central standards, like traffic laws, but the individual teams drive their own cars. It prevents the swamp because someone is actually accountable for keeping their part of the lake clean.
And I want to bring in the Caltrans case study because it proves this isn't just for tech startups. We're talking about the California Department of Transportation.
A massive, complex, and typically very risk-averse government agency.
And they're implementing this stuff, but they didn't just go out and buy a magic AI box.
No, and this is the key lesson. They used a strict, phased approach. And phase one wasn't, let's automate everything. Phase one was just system administration.
Which sounds incredibly boring.
It is. It's user management, security settings, digitizing paper forms. But Caltrans understood that you cannot automate a process that exists in a filing cabinet.
You have to digitize before you can optimize.
That's it, right there. They took the time to get the boring foundation right so that later they could layer the cool intelligence on top. If you skip that step, you don't get digital transformation, you just get digital chaos.
So let's bring this all back together. We're sitting here in early 2026. We are watching an $89 billion surge in physical infrastructure. It's liquid-cooled, it's power-hungry, it's massive.
And inside those shells, we are deploying this postmodern software stack that's moving from passive dashboards to active autonomous agents.
We're seeing digital twins that don't just mimic a building but actually run the building, and edge devices that make safety decisions in milliseconds.
And the single theme connecting all of it is integration. The walls between the physical world and the digital logic are just dissolving. The building is the computer now.
But I have to leave you with this one thought that was nagging me through all these reports. We keep using these words: autonomous, agentic, self-healing.
The systems are closing the loop themselves.
They're closing the loop. The Siemens system cools the building without a human. The inventory agent restocks the warehouse without a human.
Which raises the ultimate question, doesn't it?
It does. If the building manages itself, and the supply chain runs itself, and the data cleans itself, in 2030, where does the human actually sit?
Are we the architects designing the system, or are we just the passengers living inside of it?
That is something to think about next time you see a crane on the skyline. Thanks for diving deep with us.
See you next time.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Looking for more knowledge and inspiration? Head over to our website. You'll find everything you need to keep building smarter.